Hello, my name is Brian Alder, and today I will be completing two problems from video assignment 24 that specifically involves 11.10 Taylor series. Alrighty, so the first question is asking to find the Maclaurin series for f of x equals sine of 3x squared. Okay, so to begin with, we need to recall that the Taylor series for sine of x is equal to the sum of n equals 0 to infinity of -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. So now that we basically have a basis for this Maclaurin series, we can substitute u for 3x squared, so we can get sine of u equaling the sum of n equals 0 to infinity of -1 to the n times u to the 2n plus 1 over 2n plus 1 factorial. So now that we have u put in for 3x squared, now we could just bring back the 3x squared and combine everything. So we have sine of 3x squared equaling the sum of n equals 0 to infinity of -1 to the n. And now that we have 3 times x squared, we can basically separate the 2n plus 1 when we raise to power to get -1 to the n multiplied by 3 to the 2n plus 1. And then we can multiply that by x squared 2n plus 1. And that's all over 2n plus 1 factorial. Now you can leave this answer like this, but if you want to simplify it down one more step further, we get sine of 3x squared equaling the sum of n equals 0 to infinity of -1 to the n times 3 to the 2n plus 1 multiplied by x to the 4n plus 1, because since we have x raised to a power, we can just distribute that 2 to the 2n plus 1. Oh, I'm sorry, it wouldn't be 4n plus 1, it would be 4n plus 2, because 2 times 2n is 4n, and then 2 times 1 is 2. So we have all of that still over 2n plus 1 factorial, and this would be your answer for the first problem. Alrighty, so now let's jump into the second problem. So it's a true or false question. It says true or false, the power series expansion for f of x times g of x at 0 is given by f of 0 times g of 0 plus f prime of 0 times g prime of 0x plus f double prime of 0 times g double prime of 0 over 2 multiplied by x squared, and then the pattern would just keep going on and going on. Okay, so to begin this problem, since we have two different functions being multiplied together to find this power series expansion, I believe that the easiest way to go about to see if this statement is true or false is to calculate the power series for f of x and g of x individually. So we will do f of x equals the sum of n equals 0 to infinity of f of 0, because when you plug in 0 into your function, you're going to get whatever answer that is. And then you would add the first derivative of 0 over 1 factorial, and then keep going on with the pattern. So you would do the second derivative of 0. Oh, I forgot. After you do the original function and you take the first derivative, you get an x here. So then you would add the second derivative of the function at 0 over 2 factorial multiplied by x squared. And then that pattern would just keep going on. So next, when you do g of x, it's going to be pretty similar to the power series of f of x, except it's going to be a g. So we got g of 0 plus g prime of 0 over 1 factorial x plus g double prime of 0 over 2 factorial x squared. And then that pattern will also keep going on. Okay, so it's saying that the pattern for f of x, g of x at 0 would be f of 0 times g of 0, and then their derivatives multiply together, and then their second derivatives multiply together, and that pattern keeps going on. But when you look at what you have to do, if you multiply the two functions as they are right now, you can't just multiply them together to get the top one, because in order to do that, it would just be like simple multiplication that we learned in elementary. You would have to multiply each term by every other term in order for the statement to be true. So, like for instance, after you do f of 0 times g prime of 0, you would then have to do f of 0 times g prime of 0. And then you would have to keep going on with the rest of these numbers until you get the series. So, because of how the phrase is stated above, that statement is false. Thank you for watching this video, and I hope this was able to help you in any way, shape, or form you have for Calculus 2. Thank you.